Here is a problem in ALEKS that you're going to come across where we're being asked to graph the equation y equals -3 times the absolute value of x minus 2 plus 3. So as you can see, we have multiple transformations going on in this, and I just wanted to kind of show you, in my opinion, the best way to go about graphing this. The first thing I always recommend finding with these types of problems is your new vertex. Remember, the old vertex always starts at 0, 0 because the absolute value of 0 is 0. But in this problem, you can see that there it says x minus 2, which tells me we're going to move to the right 2 spaces. Remember, if it's a minus on the inside, we're going to the right. If it's a plus on the inside, we're going to the left. So we're going to the right 2 spaces. All right, so that's right 2 spaces. But then the plus 3 in the back is going to make us go up 3 units. So instead of being at 0, 0, we went right 2 spaces and up 3 spaces. And this is actually our new vertex right here. So I'm going to erase these points. This is our vertex. Now, the only transformations we have to consider is that -3 in the front. So negative means that instead of going up, we're going to be opening down. And the 3 tells us how much we are stretching by. So I would go right 1, and I'm going to go down 3 units because we have a vertical stretch of 3. And in the absolute value case, that means our slope, in this case, is -3 right here. And so on the left side, I go left 1, and I go down 3. And this right here is going to be enough to draw my absolute value graph. And so that's what it would look like. So we have our V shape. Our vertex is 2 units to the right and 3 units up. And as you can see, we're reflected over the x-axis because it's upside down. And the stretch is 3, and you can see that by looking at the vertical travel distance from the first point to the other 2 points, right? It's went down 3 spaces on each side. And so I'm going to press check just to prove that this is actually the answer. And it is correct. All right, and so there you go. That's how you can do these problems in ALEKS.